Hello everyone. So today I'm going to start a series where I walk through various design choices and, just me building my game in a presentation style. And I think that this will be, really helpful because unlike, I think, short form content or, more viral kind of, content, I think this kind of encourages, a slower, more intentional kind of approach to game design and can be really helpful in, thinking and analyzing about, more granular game design, ideas and stuff. For those who may have watched my videos, previously, this is more technical and this is more involved with the implementation of code. So, yeah, let's begin. So, this is about how to design a UI manager engine in Godot 4.5.1. And, so let's start. Excuse me. Why would we want to build a UI manager? So, first, a UI manager seems like it's a lot of work, right? We could just pull in, various objects, when we push buttons to control them, right? Like, if we have a player object, we can just have a, check the input state for which buttons are being pressed and then have it move around that way. Isn't that easier? Well, there's actually a lot of reasons why having a UI manager is actually the better way to go. See, it has consistent behavior across the whole game. So basically, you know what this is doing, right? It makes timing much easier to manage, right? Because you're concentrating all inputs within the UI manager, right? It's easier to debug. So because, again, inputs are controlled by the UI manager, right? And the UI manager controls, what you can do at any given time and things like that. It's just easier to figure out what's going on. There's more structure. It cleanly handles input and modal windows, right? So, by input, I mean just, you can add an input module onto it, and you can easily, set up different inputs for different kinds of user interfaces. And it also supports modal windows. So modal windows are like pop-ups, right? So, when you're playing a game, you may have, a menu pop-up, and then when you're interacting with that menu, you might have, another pop-up show up. This engine very cleanly manages that, right? And it can be used for all user interfaces. It doesn't just have to be menus, right? So it can be, the main gameplay interface, things like that. It can be used for any of that. But isn't that aberrant? What we mean by aberrant, by the way, is essentially having a hierarchical and authoritarian structure that is imposed upon the concept of game design. So, am I imposing this structure upon game design? Well, not really. We don't have to design video games the way I do. You can design games any way you want. It's just that it's valuable to analyze the way that we build machines so that we can build new ones in the future. The real problem is when we keep doing the same thing over and over. Remember, you can build this any way you want. This is just a guide to explain my design principles. You can use the repository in the description as a reference, or even use as a base for your own implementation or projects. It's open source, so I don't really care what you do with it. This guide is made for Godot 4.5.1, but other game developers may find this guide useful. Part 1. Game Controller. What is the Game Controller? The object that structures the game loop and access to its basic resources. So basically, the game controller is an object that I'm creating to basically override the general lifecycle functions of Godot. And the reason why is because I want to use Godot's resources. I want to use Godot's structures, but I don't want to use the way that Godot forces me to interact with the user interface and all that. And the reason why is because I really want to concentrate all of my inputs and all all of my interactions in one place, and I want to abstract them before they are processed by the game. The reason for this is because not only does it make it easier to do all those things that I mentioned on the previous slide, but I can also expand my game to potentially interact with other software that's running alongside my game and use it for, different kinds of things. For example, maybe a different kind of output for specialized users or things like that, right? It manages inputs, options, save files, and advancing the state of the game, among other things. It manages inputs, options, save files, and advancing the state of the game, among other things. So basically what it's doing is it's controlling the control flow of the game and how the game interacts with things like the options, things that are saved to a file, input states, and there's going to be more that is managed here, but for now, that's basically what it does. This way, critical functions are all stored in one place. Let's talk about the Godot implementation. See, Godot already manages its own game loop structure, so we are basically using Game Controller to override this. The Game Controller is a node that can be added to the global auto load nodes. So if you go to your project settings, you can go to the auto loads, and you can add a global that way, right? That's what we're going to do with Game Controller. This allows you to reference it at any time in the script. It's very valuable. The functions it has creates a useful way to interface with various global game functions, right? So, essentially, it allows me to, access various parts of the game at any given time that allow me to, change, user interfaces, change the UI canvas, change, what's loaded at a given time. It's very valuable for controlling those things. Oh, yeah, and it also has an options interface as well. It has other objects and nodes that control its behaviors. So basically it has these children that it's managing that control, the details, right? And I didn't mention this in the slideshow, but a big part of the reason why we choose to make something a node instead of an object is whether or not we want the particular thing that we're making to be in the node tree, right? If we can avoid having it in the node tree, we'd rather have it be an object, because nodes are actually more intensive resource-wise than objects. Objects are more lean, right? It's not like something that would impact a really small game, but those things do add up. So it's good to just, if it's something you can take care of that's not going to make your code unmanageable, these kinds of small optimizations are not really problematic. More on the Godot implementation. Godot also has a feature that loads the first scene. This is also a problem because we have to create a scene that will load, that destroys itself as soon as the game is loaded, its first UI canvas. Now, UI canvases are where we store the UI objects to display them, and it manages the stack so that we can display things, but we'll talk about that more later. But this allows us to have a way to initialize the state of the game controller. So basically, how this works is we use the main scene as kind of just like an entry point for the program, right? And the main scene will execute a little code that starts the game controller with a default canvas, right? And then it will destroy itself, so then all control is passed to the game controller. And, I guess you could make it so that the game controller scene is the main scene, but I just prefer to do it this way, because I'm weird. Part 2, UI Manager. What is the UI Manager? Ooh. The UI Manager is an object that manages the UI in particular. It manages multiple UI canvases, which are used to display user interfaces. My implementation also handles transitions between loading between UI canvases. Actually, this last part is not true. I actually changed the code shortly after finishing this presentation, and I forgot to change this. My code actually has the transition code in Game Controller, and the reason why is because it was a couple of refactors, essentially trying to convert nodes into objects as an optimization. So actually, the transition code is actually based in game controller if you're going to look at the source code. But yeah, basically the UI manager just manages the state of canvases, right? And like I said, canvases contain the UI objects and their arrangement. And the UI objects is where things like the inputs and all that are stored. But yeah, again, we'll go into that later. Godot implementation. The UI manager inherits object, and it is instantiated when the game controller is instantiated. It's part of its on-ready stuff. The UI manager can create, free, and cache UI canvases. This function is actually part of this function. No, actually, okay. So the creating, freeing, and okay. Let me restate this. I'm gonna cut that. The UI manager can create, free, and cache UI canvases. So basically, it can manage the UI canvases from its object. And each idle and physics frame, it will process the idle and physics frames of the currently selected canvas, right? So it will just, like, so you can swap between canvases, right? That's what the transition is for. It's to allow you to essentially swap between the canvases without, like, causing, like, weird visual bugs. Basically, the currently selected canvas will have its idle and physics functions called each frame, so that they can be processed. And this is not the same, by the way, as process and physics. We will go over that later in the input section. But they're different because you're actually passing the input state that you received at the beginning of the frame. So when these things are processed, they're just processing the input state that is passed to them. UI canvas references a list of whitelisted UI canvases and input modules to instantiate, and supports caching packed scenes and scripts for later. Just FYI, this particular functionality of whitelisting is actually now contained in game controller. I felt like that was a better place for it, but basically that function still exists. And the reason why we use whitelists is because this reduces malicious activity. Now, I understand that, you know, I design things with the assumption that I'm not going to catch everything. You know, it's kind of impressive to see what people can do, but I should still build things that make things more sturdy, because at the end of the day, it's not just a malicious attacker that might cause problems, or like a malicious mod, but it may even just be my own bad code. So having something that is more vigorous and ensures that, you know, it's running what it's supposed to be running, and not something that kind of is similar, that I just wasn't paying attention because I was really sleepy one day, and it's like a weird edge case, you know, that just makes sure that you don't have a scenario like that, right? This is a kind of coding that is less about producing the most optimized code for the computer, and more about producing the most optimized way to ensure certain behaviors in the programmer, right? And whitelisting is really more about, you know, programming the programmer's behavior in a way to ensure that kind of safety, right? Let's talk a little bit about transitions. Now, technically the transitions are in the game controller in the source code, but this is still, all of this is basically true. So UI canvases can be switched with no animation, but transitions allow for animation to be easily controlled between changing canvases. As soon as a transition is triggered, the input module is unloaded from the UI manager. This disables all input. So basically, when there's no input module in the assigned to the UI manager, it won't even try to pull. Right? It just won't do anything. The transition continues until the first half of the animation is complete, which covers the whole screen and basically obscures what's going on. And both processing of the old and the new canvas, as well as a possible custom lambda function, is called here. So basically, the old is popped and runs a routine. Then the new runs its own routine when it's pushed. And then there's also a lambda function that you can also call after that you can do your own custom stuff if you want to do that, right? After a set amount of time, the animation loads the input module again, allowing for inputs. So the reason why I did this is because without this kind of design, you would have to wait until the end of the fade out animation in order to be able to move again. And that's really annoying because you have to wait for every single pixel to be done with that animation. But this allows you to finish before the animation is complete, so you can still do things, but it doesn't cause any sort of jank, right? And again, like I said, you know, things are still always possible, but I like to design, you know, more intentionally, right? After the second animation completes, the transition resets, and if the input module has not been loaded, it is loaded at this time, right? So that way you're not just soft-locked. Transitions use special class that inherits animation player that checks if options are checked to skip the animation. These are usually aesthetic or accessibility based options. We'll talk a little bit about this later. UI canvases. What is a UI canvas? The UI canvas is an object that stores many UI objects in a stack. A stack is used so that the modal dialogues and menu stacking can be easily supported. So for example, imagine you are on the overworld, right, of some game, and then you press the start button. That would push the start menu on the stack, right? Now let's go and say I want to check my inventory, and that pops up another menu. That puts the item menu on the stack, and then I'm going through the items, and then I want to toss an item. That puts another modal on top of that. That adds another item, UI object onto the stack. You kind of see where this is going, right? The stack manages the structure that determines you know, what is able to be controlled at a given time and how I can access those menus. It's very, very easy once you get used to it. The UI on the top of the stack is the one that is actively processing inputs or changes. So the UI canvas is not just processing all of those at once, it's just processing the top one, right? If you want to process the lower ones, you're going to have to write code that actually does that. Implementation in Godot. The UI canvas's inherent node, and it is placed in the node game controller UI. I believe the reason why it inherits node is because it's something to do with the drawing. I don't remember. It might be object. I'm not sure. Just check what it is in the source code. I may have forgotten this in the presentation, but it's a minor thing. It uses an array designed with a stack interface to allow you to push, pop, and peek top the stack. UI Canvas also allows you to easily create new UI objects. Like the UI Manager, the UI Canvas references a list of whitelisted, and this is, again, the whitelist is in Game Controller, but it's basically another whitelist that controls which UI objects the UI Canvas is allowed to make. Default UI is loaded based on its key name. So each UI Canvas object will have the default UI. It will have a default UI defined, basically, right? And it will create the first UI, the base UI of the canvas based on that, right? And the thing about this UI is that it should actually not be popped, right? Because if you pop the whole stack, you lose all input, and that soft locks the game. And this version of it, because it's a debug mode, actually will send out an error under those conditions. So it basically, the bottom layer is always going to be there. Part 4, UI objects. What is a UI object? UI objects are the actual UI elements that the player will interact with. It's not just used for menus, it can be used for 2D or 3D games using viewports. Allows for the UI to be switched easily and controlled by the UI Manager. Contains information about what the input module to load is when it's on top of the stack, right? So basically, what these UI objects do is that UI objects, essentially are just the menus or the user interfaces themselves. They have a reference to the input module that is loaded when they are active, and essentially they take the input from the module and they'll update the state based on that. And they only update the state of the object that's on the top of the canvas stack. So the implementation in Godot. UI object inherits control. Root node of the UI scene is UI object. Children can be whatever is compatible with control nodes. Input module is defined by its string key. It is loaded manually. This again forces the input module to be initialized in a way that forces conscious development of when inputs start pulling to avoid bugs. If you type it incorrectly, it's going to say, hey, this is not a whitelisted command, right? So it's just another layer of, yeah. Input management. What is input management? A design that manages the interface between human interface devices, controller, keyboard, controller, keyboard, mouse, etc., and the game. Many games pull for inputs in the idle frame. This is bad game design. This makes inputs more difficult to debug. This makes it harder to add new kinds of inputs. This makes it harder to control how inputs are interpreted by the game, and sometimes inputs are pulled far more often than they need to be, and this uses up CPU cycles. Generally in more modern games, this isn't necessarily a problem, but it can be a problem, so keep an eye out for it. What is input management? By managing inputs all at the beginning of the idle frame, before any other processing is done, we have a few advantages. We can consolidate inputs all in one place and transform all inputs into the same type of data structure, so that they can all be used by the game in the same way. The data structure can represent abstract data like movement or direction instead of inputs, making it easier to design the core game logic. So basically, what we're doing is, instead of doing this stuff in the idle frame for different objects, we're consolidating it all in one place. We're saying, okay, what should happen on this user interface when I push the up button at any point, right? It should be like, okay, if I'm pushing the up button in this particular interface, it should move me forward, it should move me backward, or whatever, right? And that movement is what's actually communicated from the input interface to the core game logic, as opposed to just the inputs themselves. You can do the inputs, but there's more flexibility here. That's kind of the point. More organized and easier to work with within development, and optimizes input polling and prevents unnecessary polling. How can we design input management? We can create input modules that are referenced in the UI objects that record the input state and then reference them in the game controller. The game controller pulls the input state for the two main threads in Godot, idle and physics. It then stores the result and passes the input result to the currently processing UI object, respective to idle and physics frame. Notes about Godot. Godot has two kinds of process frames, idle and physics. Idle runs at a variable FPS, while physics runs consistently at the game's designated frame rate. You need to process separate input management for both threads to ensure both threads have an up-to-date input state. So basically, you'll need to update the state for both physics and idle every frame. So you're actually processing input twice a frame. Notes about Godot continued. Godot will process idle and physics frames by default. You will want to avoid using process and physics process in your UI objects because you can't control exactly when these objects are called. You should still enable physics and idle frame processing because this will update collision calculations, animations, and other functions. So basically, the core aspects of Godot are kind of noodled together a bit. So you don't want to use the process or physics process functions. You want to keep them blank because you don't want them to do anything, but you still want to keep the processing enabled because if you disable the processing, it will pause things like animations and physics and stuff like that. You don't want that. Godot has default inputs for control elements that you may want to delete so that you have full control over the interface. And basically, this is all those default inputs that they have at the beginning, and they've added a lot more, and it's really tedious, so have fun deleting all those. I sure did. Part 6. Other design notes. Caching. Caching is storing some data in memory so we can use it later. So basically, this is let's say I make an input module, right, for checking menus, and we're going to use this input module a lot. So we don't want to instantiate a new version of input module every single time when it does the same function every single time that we call it. We should just have it so that it can just reference that same input module over and over again without having to recreate it, right? That's what caching is. This way, we don't have to go through the steps of recreating things all the time. That's really annoying. Input modules, UI canvases, and UI objects can all have their templates cached. There's two kinds of caches in my model. There's the default, which are always preloaded, and they're preloaded at the beginning of the game, and they're always going to be checked. So things like really important kind of inputs, like menu input, right? Menu input is probably going to be the same for almost every single kind of menu you're going to see on the screen. So we're going to want to preload that because it's going to be in memory at all times, and we can just use it whenever we need. but we can also have user cached inputs, right? So let's say we have like a special scene, right? And this special scene switches between a few different kind of input types. Like for example, like let's say it has like a special overworld input, right? And we need to switch it several times, right? Like let's say we're going between a boat and we're going between like flying a plane or something, and they have different input modules that work slightly differently, right? We may want to keep all those in memory so we can reference them when we need them instead of recreating them every time that it's created. And this will save, runtime. This will make things run faster, right? It does require more memory, but in most cases, I think it should be fine. Now let's talk about accessibility. Even though we have not designed any UI objects yet, we can still implement an accessibility feature, reduced motion. Reduced motion is very important for people with migraines. Animations can have their animations skipped to the end, so they are not displayed. They can also have their animations replaced with a fade. So basically how reduced motion is implemented in this game is that I created a custom animation object that plays the animation, but it can skip based on the values of certain options, and it will skip to almost the end, so that way the next time that the animation updates on the next frame, it will reach the end and it will trigger all of the completion signals and stuff. You don't want to have it go all the way to the end, because that can actually cause it to avoid triggering those signals. The transition animation defaults to a simple fade out if reduced motion is enabled. This way the animation is still there, but it's not something that's gonna cause issues for people's eyes. Source code is in the description.